Hi, this is Professor Eckhouse, and I'm going to talk about graphing linear inequalities. So the first thing we need to look at is how to do it. So the steps are here. I'm not going to read you every little bit of it, but the basics are that first we graph the line, and then we decide where to shade. And we're going to talk about the details of that. You might want to pause the video and get these steps into your notes. Okay, so let's try an example of what I just showed you, because I know it doesn't really mean much until you try it. So we have an inequality given right here, and it looks just like an equation, except it's all the numbers that satisfy that left side that are less than or equal to 12, all of them. That means there's a whole region, not just a line. And there's a couple of things we need to think about before we begin. One is, what is the line going to look like? So if it's less than or equal to, the equal to means it includes the line. If it is less than, it would not include the line. It would just be a boundary and it would be dashed. But this is going to be a solid line. So that's the first thing you should do, is always decide if it's going to be dashed or solid. So this would be dashed, like I said up above, and these choices would be solid. Okay? So that's our boundary, and we don't want to know if it includes it or not. Then the next thing we need to do is we need to draw the line. So that means that we are going to be dealing with this equation as an equation, not as an inequality. We're just going to look at it as an equation and graph the line itself. So the way we've talked about doing that so far is to choose intercepts. So let's make x 0. So we're looking at the y-intercept. And we're going to then figure out what y would be. So if x was 0, then we would have, remember, this is going to be an equal sign because we're just looking for the line, not for the shaded portion. So that's going to go away, and we get negative 4y equals 12. And then you're going to divide by negative 4. And you're going to get y equals negative 3. So I'm going to put negative 3 right in here. So remember, what we're finding right now is the line itself, not the shading. All right, so let's find the other portion. This is the one where y is going to be 0, and that is the x-intercept. All right, so we've got 2x minus 4 times 0 equals 12. Remember, it's equals because we're looking for the line, not the shaded portion. All right, so this goes away, and we get 2x equals 12, and so that means that x equals 6. So we'll put 6 right here. So now we have 2 points. 0, negative 3, which is right here, and 6, 0, and that is right here. Now we decided before that it was going to be solid, so we'll try to draw a straight line. There we go. And put some arrows on it. And now we have to decide, now the second portion, that was step 1. Then step 2 is to figure out where the shading is. So where is the shading? All right, so the easiest thing to do, well, what you want to do is pick a point and put it back into the 2x minus 4y is less than or equal to 12. We already did the equal. Now we have to do the less than, right? So that's what we're looking for. So what point would you want to pick? Any point. So if you picked a point over here and it was true, then that means everything over here is true. If we picked a point over here, and that was true, then that means everything over here is true. So, let's see. Let's think about this. What point would be easiest? Hopefully you guessed it. 0, 0, right there. And if not, now you know. 0, 0. You can pick any point you want, and it does not matter. But generally, we want to pick 0, 0. So we've got 2 times 0 minus 4 times 0 is less than, we're really just looking at less than 12, because the equal to is the line. All right, so that means 0 is less than 12. Is that true? And that is true. So we want to say, yes, it is true. So this side over here is true. That point is true. So that means the whole side, everything is true. Because there's our graphed inequality. It includes the line and the shaded portion. So infinite numbers of points on the line and infinite number of points in the shaded region above the line. All right, here's another one. It's in a different form. It's not in standard form, but why don't you give it a try? All right, step 1, you want to look at whether it is dashed or solid, and this one is going to be dashed. So think about that right away. That way you don't forget to make it dashed if it needs to be. Okay, the next thing we're going to do is we are going to make the line, our dashed line, but we have to find some points so we can do that. So I'm going to make x equal to 0, and I get 3y is equal to 6 times 0 minus 12. So 3y, this goes away, equals negative 12, divide by 3, and I get that y is equal to negative 4. Okay, and then the next point could be the other 0. That's pretty easy. Makes it simple to put zeros in. 3y equals 6 times 0 minus 12, right? And I say easy because we're trying to make it easy for ourselves by putting zeros in. It's just less math. All right, so this goes away and we get 3y. Oh, I put it in the wrong place. Did you catch me? I made a mistake. All right, so we want to put the 0 in to the y. So 3 times 0 equals 6x minus 12. So we get, this goes away, and we get 0 equals 6x minus 12. So at this point, I could bring the 6x to the left, but then everything would be negative, and people make more mistakes with that. So I'm going to bring the 12 over to this side, and I get 12 equals 6x, divide by 6, and I get that x equals 2. It doesn't matter which side x is on when you're just dealing with an equation. So I've got 2, 0. All right, so 2, 0 is right there, and 0, negative 4 is right here. And let's talk about let's just do one more point, because sometimes the intercepts don't always work very well. You get like a fraction, and then you're putting it in online, and it doesn't have fractions. It only has whole numbers. You'll see this in the homework. So let's just just pick another point. It doesn't really matter what point you pick. So what if I made x equal to, I don't know, 3? Let's just make it equal to 3. So we've got 3y is equal to 6 times 3 minus 12. So 3y equals 18 minus 12, so that's 6. So 3y equals 6, divide by 3, I'm running out of room, and I get y equals 2. So there's our another point. So we've got 3, 2. Does that look like it falls on the same line? It's a great way to check that you didn't mess up the first two. Let's pick one more point. It always, especially in a test, is a good idea. All right, so now we've got to draw our line, and before we decided already it's going to be dashed. So let's make a dashed line. It goes on forever in both directions, so put your arrows. So now we need to decide the second step, really. The second step is to find the shading. All right, so the shading is going to go where? Well, what point do you want to pick to test this? And remember, we want to use the inequality. 3y is greater than 6x minus 12, because we're looking now at the portion that's greater than, not the line. When we're looking at the line, we say equals, and when we're looking at the shaded portion, we leave the inequality. All right, so what would be an easy point? Well, let's put in 0, 0. Let's put in this one right here and test it and see if it's true. So 0 is greater than 0 minus 12. Why didn't I say 3 times 0? I just took a little shortcut because 3 times 0 is just 0. All right, so I get 0 is greater than negative 12. Is that true? Yes, it is. So that means this is true. That means everything up here is true. And I just want to point out that these sometimes don't rely on the greater than. Don't think, well, it says greater than, so it must be above, because take a look up here. This one said less than. So intuitively you would want to put it below, but that's not where it is. It's above. Okay, so don't just go with the sign, because it depends on the equation. Sometimes it's going to be above and sometimes it's going to be below. All right, so now we're going to look at identifying whether an ordered pair is in the solution set of an inequality. So from a graph, it's very straightforward. Anything that is in the shaded portion, so remember, a solution is an ordered pair that makes an equation true. Now this time we're looking at makes an inequality true, right? So now we're looking here at an inequality. So we're not just looking at the line, we're looking at the shaded portion. And you've also got to think about the line. So let's look at the shaded portion first. So which points are in the shaded portion? Well, that would be this one, this one, this one, and this one. So those are all solutions. What about this one? It's on a dashed line. The dashed line means that the line is not included in the solution, so that is not a solution, and neither are the red ones. Okay, so this is how you do it with a graph. What if you're given an equation and asked which ordered pairs are solutions? Well, they're the ones that are going to make it true. So I'll do the first one for you, and then let's look at, I'll let you try the next two. All right, so we want to say y is less than negative 3 x plus 1. So we want to take these points and put them in. So negative 3 is less than negative 3 times 2 plus 1. I think I need a little more space here. All right, so we've got negative 3 is less than negative 6 plus 1. Negative 3 is less than negative 5. Is that true? No, it is not true. Not true. So this is not a solution. All right, why don't you pause the video and try the next two. All right, I'll do the next one here. So we've got negative 5 is less than negative 3 times 1 plus 1. Negative 5 is less than negative 3 plus 1. So that's negative 5 is less than negative 2. All right, is that true? Yes, it is. Yes, it is. So that one is a solution. All right, last one. You should get 2 is less than negative 3 times negative 3 plus 1. So 2 is less than 9 plus 1. 2 is less than 10. Is that true? Yes, that is true. So that one is also a solution. All right, so the last topic, just a note on using the homework graphs. So this should be my open math. I fixed it and it didn't save. My open math graphs. All right, so we're going to use the intercept method to find 2 points, or just pick points. So use your method to find 2 points. Determine if it will be shaded or solid. Test a point to see which side will be shaded. So all of this needs to be done on paper. Do not try to do all of this in your head. It's too much, too many things, and there's too many places to make mistakes. Now, once you figure this out on paper, you're going to put your answer in by choosing which type of line. Right down here, is it a solid line or is it a dashed line? And then what you're going to do is you're going to tap the 2 points, your x and y intercepts, or whatever 2 points you've chosen. So if my 2 points were, say, I don't know, I'm just going to pick a couple. Let's just say they're here. This is not correct, but here and here. I didn't work this problem, but here and here. And we know it's going to be solid, right? So we're going to choose this tool right here. Okay, so choose the tool, tap here. Let me erase those so I can do this in order. I'm going to erase this. All right, choose the tool, tap your point, tap your other point, and you've already decided, and so it will automatically do a straight line for you, a solid line. And then it's waiting for you to tap where to shade. So let's say you want to shade to up above, so then you would tap right there, and it would fill it all in for you and shade it. Okay, so 3 taps. That's how you do it. All right, thanks for watching.